Okay, so for geometry in 3.2 today, we went over proofs and perpendicular lines, and we had three theorems that we're going to start off with. The first theorem was if two lines intersect to form a linear pair of congruent angles, then their lines are perpendicular. So the picture is describing over here, if two lines intersect and they form a pair of linear angles, a linear pair that are congruent angles, then you can say that the lines are perpendicular, right? So we looked at this one over here and found that, sure, we could create a linear pair out of angle 1 and angle 2, but since angle 1 and 2 are not congruent, that tells me that these two lines right here do not intersect to form right angles. So that's what theorem 3.1 is trying to tell you. Okay, 3.2 says this, right? If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. And complementary means they have to add to 90 degrees. So take a look at this picture here, right? Two sides of adjacent acute angles are perpendicular. So here is a right angle, okay? And I can break up that right angle into two different angles, angle 1 and then angle 2. Right? Well, if these are right angles, then angle 1 and angle 2 have to add up to be 90 degrees. They're complementary. And it doesn't matter how you break up those angles, still complementary. That's what 3.2 is trying to tell you there. And then 3.3 we went over today. If two lines are perpendicular, then they intersect to form four right angles. So here, as you can see here, I got two different lines. We'll call this line A and we'll call this line B. So line A and B intersect and they are perpendicular. Therefore, I have created four right angles, 1, 2, 3, and 4. And then we went around the room today and looked at the windows and looked at the ceiling and the floors and all the pictures around here. And we had plenty of examples of theorem 3.3. Okay. Then we did a proof together in class. And here was the proof we did, okay? So we were given that BA is perpendicular to BC. Okay, that's what we're given. We're trying to prove angle 1 and angle 2 are complementary. So essentially, we're trying to basically prove theorem 3.2 back here. That's the one we're trying to prove. And since it is a theorem, it can be proved. So here is what we did, right? We start with the given. So BA is perpendicular to BC because it's given. Well, if it's perpendicular, then that means that angle ABC must be a right angle. That's the definition of perpendicular lines. So now we know that. Well, if ABC is a right angle, then ABC must be 90 degrees. Right, so I'll highlight these as we go, right? So we did that one now here. So ABC must be 90 degrees because it's a right angle. That's the definition of right angle. Okay, now we need to relate angle ABC with angles 1 and 2. So we came up with the measure of angle 1 plus the measure of angle 2 is equal to ABC, and that's just the angle addition postulate, because you can add two angles together to make one big angle. Well, since the measure of angle ABC was equal to 90, we substituted that in for a new line, and of course we called it substitution, and that's exactly what we were trying to prove, because if angles 1 and 2 add to 90, then angle 1 and angle 2 are complementary. That's the definition of complementary angles. So we did that one, we went over it, we made sure we answered all the questions, so make sure you can read that one and follow the logic from it. And then we gave everybody a proof to do on their own. And here's what we got, right? I gave you a U-try, so we got the groups and they tried it by themselves. So we're given that AB is equal to CD. So that means that AB over here, I highlighted it, is equal to CD over there. We're trying to prove that AC is equal to BD. And I gave you 3 clues along the way, although most people figured it out after the second clue. Okay, so first we'll start with the given. AB is equal to CD. That's given. No problem. Then we're going to add the same thing to each side. We're going to take AB plus BC equals CD plus BC. And adding the same thing to each side is called the addition property of equality. Now, what does AB plus BC actually equal? Right? AB plus BC equals AC. Right? So AB and BC together equal AC. And then likewise, CD plus BC is equal to BD. So CD plus BC is equal to BD. Right? So all that stuff. And that's just the segment addition postulate. Well, therefore, if these two things are equal, AB plus BC and CD plus BC, as it says in example 2, we can substitute that in around here to get that AC is equal to BD by substitution. And most people were able to get that. So make sure you look over that and understand all that is here for you. All right, good luck.